everyone, welcome to the series of science lessons. This is the continuation of the previous lecture, Equations of Motion by Graphical Method. These are the equations of motion for an object along a straight path. Here V is final velocity, U is initial velocity, A is acceleration, T is time interval, and S is total distance travelled. V is equals to U plus AT, S is equal to UT plus half AT square, and 2AS is equal to V square minus U square. Now let us derive one by one using graphical method, starting with V is equals to U plus AT. Equation for velocity-time relation. Velocity is on the vertical axis and time is on horizontal axis. You can notice the initial velocity is not equal to 0. Initial velocity has got some value, and final velocity is this, and OC is the time interval. We can notice there is a uniform acceleration. The rate of change of velocity over time is uniform. As the time increases, there is also a uniform change in velocity. Now let us derive V is equals to U plus AT. This is the length of final velocity. OA is the length of initial velocity. This is the time interval T. We can notice that BC plus DC is equals to, we can notice that the length of BC could be written as BD plus DC. We know that the length of BC is final velocity, and you can also notice that the length of DC, this length of DC, which is equal to OA. These two are equal. DC could be rewritten as OA. What is OA? OA is initial velocity. BC is final velocity and OA is initial velocity, and BD as it is. We will come back to this in later part. So we can write BD is equals to V minus U. Acceleration A is defined as change in velocity over time. Here the change in velocity is V minus U, right? Change in velocity is final velocity minus initial velocity, V minus U, over time interval OC. The length of OC is time interval, right? V minus U divided by T. When we rearrange these terms, we will get AT is equals to V minus U, or V is equals to U plus AT. Equation for position-time relation. Let us imagine that an object has travelled distance S under time T in an uniform acceleration. The distance travelled by an object is given by area of this part. Vertical axis times the horizontal axis. In vertical axis we have velocity, and in horizontal axis we have time. Velocity times time is equals to distance travelled, right? Yes, so we need to multiply the vertical axis times the horizontal axis, which is nothing but we are calculating the area under this part. We cannot directly find out the area for this graph, so we need to divide into two parts, this part and this part. This is the area of rectangle and this is the area of triangle. Now let us calculate the area of rectangle. So the distance travelled is total area under this graph. Now let us prove S is equals to ut plus half at square. So the area under this graph is a combination of two parts. Area of this triangle plus area of this rectangle. Now let us calculate the area of rectangle. So the total distance traveled is equals to area of this rectangle plus area of this triangle. So S is equals to area of this rectangle. Length into breadth. Length is OC. OC is time interval T, and breadth is DC. We know that DC is equals to OA. Length of DC is equals to length of OA. OA is initial velocity U. T times U. This is the area of rectangle. Now let us calculate the area of this triangle. Is equals to half into base. Base is the time interval T, and the height is BD. From the previous proof, we know that BD, this length BD is equal to acceleration times time. BD is equals to AT. So half times base is AD, which is equals to OC, this time interval. This and these are equal. So length of AD is equals to T, the time interval, times the height BD times BD. So S could be rewritten as UT plus half base is T into BD. From the previous proof, we know that the length of BD is equals to AT. T times T into AT is equals to AT square. So S is equals to UT plus half T times T is equal to T square half AT square. Equation for position velocity relation. There is one more way of calculating the total distance traveled. Instead of calculating the area of this triangle and area of this rectangle, we can calculate the area of this trapezium or trapezoid. Right? The area of trapezium is given by the sum of length of these parallel sides divided by 2 times the perpendicular length. So the length of the parallel sides are, the sum of length of parallel sides are OA plus BC. OA is initial velocity, BC is final velocity, and the length of perpendicular is time interval T. Notice the length of AD is equal to length of OC. So we can write AD as T. So the area of this trapezium is the length of parallel sides U plus V divided by 2 times the perpendicular length T. We can rewrite this as V plus U divided by 2 times the perpendicular length T. We know that T could be also represented as V minus U divided by acceleration A. We saw this proof in previous sections. So we will replace T with U minus U, V minus U divided by A. So total distance traveled S is equals to V plus U divided by 2. We are replacing this T with V minus U divided by A. V plus U times v minus u. This is in the form of a plus b times a minus b, which is equals to a square minus b square. In this case, v square minus u square, final velocity square minus initial velocity square. So s is equals to v square minus u square over 2a. So 2as is equals to v square minus u square. This is also one more way of calculating the total distance travelled when we don't know the time interval. All these three formulas are only applicable for objects which are in motion along a straight line. Now let us see example 8.7. The brakes applied to a car produce an acceleration of 6 meters per second in the opposite direction. So this becomes minus 6 meters per second square because acceleration is in opposite direction. So there is a deceleration. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. A car was at motion when a brake is applied that produces a deceleration of 6 meters per second square, and it takes 2 seconds to stop. Calculate how much distance does it traveled in this 2 seconds after the application of brakes. Now let us see the solution. Hope you understood the question. Understanding the question is very important while solving. Before we solve, first we must know what we are solving. What is the actual problem statement? We have acceleration or deceleration is equal to minus 6 meters per second square, and the time taken is 2 seconds, and the final velocity is 0 meters per second. Car will stop after some time. We know that final velocity is equals to initial velocity plus acceleration into time. The final velocity is 0. Car eventually stops. So final velocity is 0 is equals to initial velocity minus acceleration times time. So we calculated the initial velocity. The initial velocity when the brake is applied is 12 meters per second. Now we need to calculate how much distance does the car travels after the application of brakes for 2 seconds. So we can apply the distance formula. S is equal to ut plus half at square. So the total distance traveled is equal to initial velocity is 12 meters per second and the time taken is 2 seconds plus half acceleration times second. Acceleration is minus 6 meters per second square and the time taken is 2 seconds. 2 square is 4. 12 into 2 is equals to 24. 12 meters per second into 2 seconds is equals to 24 meter minus 6 meters per second times 2 second square is equals to minus 12 meter. 24 meter minus 12 meter is equals to 12 meter. Thus the car will move for 12 meters before it stops after the application of brakes. Do you understand why it is very important to maintain distance between the automobiles while we are driving on roads? Because once we apply brakes, automobile requires some time to slow down or come to rest. If you don't have sufficient distance, there is a possibility of getting car crashed. So always maintain some distance while traveling an automobile. The content of this recording is borrowed from Karnataka Textbook Society Bangalore under Fair Usage Policy. This video is presented by Avvari Technologies. Please do hit subscribe button to get more content. Thank you.